Hello, ladies and gentlemen. Today you are going to be doing an activity on your own, investigating slope. This is something we've kind of been talking about and leading up to, and I know you've already done an investigation activity, but now after this past lesson, our dominoes lesson, you are going to have more knowledge and information. And instead of just telling you everything, which I will eventually do, I'd like to see if you can figure out these things and make some connections on your own. We will be using this staircase to help us along. As you can see, we have a staircase, and I have some dimensions drawn on there. What you will do is you will watch this video. You will be listening to the instructions, pausing it, working on that section, and then playing the video again once you've completed each section. Let's look at this first section. I ask a few simple questions. How could the measurements be changed to make the staircase steeper? How could the measurements be changed to make the staircase less steep? Then you are going to use this picture as a reference for the next few questions. You're going to just fill them in. What is the vertical distance of each step? And what is the horizontal distance of each step? Then I want to know, what is the vertical distance between the very first step and the very last step? So what would the total vertical distance be of the stairs? And what is the horizontal distance between the first and last step? So then I want to know the total horizontal distance from the very first step to the last step. Pretty simple, right? Great. So go ahead and pause the video to complete this section on your own. And then play the video again when you are ready to move on to the next section. Okay, next section. Let's look at our measurements in the form of ratios. Remember that a ratio compares two values or numbers. Fractions are the most commonly used format of ratios. And even the word ratio, R-A-T-I-O, is right there inside of the word fractions. We can compare using ratios using the word to, using a colon, or using a fraction. So we can write the vertical distance of each stair compared to the horizontal distance of each stair by using a ratio. The vertical distance compared to the horizontal distance. So I want to know, in these next couple questions, what is the ratio of the vertical distance of one stair to the horizontal distance of one stair? So write it as a fraction. I even give you a hint. Look at your answers in number 3 and 4 to create your ratio, but using your own numbers. In number 6, I want you to create a ratio using the overall vertical distance and overall horizontal distance. Again, I give you another hint of where you can find these numbers. Then I want you to look and see, how do those two ratios compare? What do you notice between those two ratios? Is there anything you notice? There should be. If you don't notice something, keep looking until you do. Then you're going to make another ratio, but this time it's just for the first 6 stairs. What would the total vertical distance of the first 6 stairs be compared to the total horizontal distance of the first stairs? Write it as a ratio. And then, what do you notice about all 3 of those ratios? Is it the same as what you noticed in number 7? Take a look at what you noticed in number 7. Is it the same? What I want you to do is to remember these ratios, because we're going to come back to these ratios in a minute. So, pause the video, fill out this section, and then play when you're ready to go. So by now, you probably noticed that your ratio from number 5, the single stair, number 6, the complete staircase, and number 8, just the 6 stairs, are equivalent ratios. They all come down to 1/2, or 1 foot over 2 feet. This is not a coincidence. If we look at the equivalent rates that I have written below, even though they all look different, they also all simplify to the same rate, which is 50 kilometers per hour. I have 50 kilometers per 1 hour, 100 kilometers for 2 hours, and 250 kilometers for 5 hours. They all simplify, though, to that same unit rate of 50 kilometers per 1 hour. If I even put this on a graph, graphing my distance and time, we will see that all 3 of these points actually fall on a line because they are linear. They are equivalent ratios. We also know the ratios to be called rates of change. Looking at these graphs, I want you to start visualizing the equivalent ratios, our rate of change, and what it looks like on a graph. This is from these values, not the staircase values. What do you notice about equivalent rates of change on a graph? Look at the 3 pictures that I showed you and write any observations that you might have. Then I gave you a graph for our staircase. I want you to put a point on each of the 3 ratios that you found. For the 1-step, horizontal distance to vertical distance, for the 6-step, vertical distance to horizontal distance, and the entire staircase, vertical distance to horizontal distance. Tell me again, what do you notice? If you don't notice anything, keep looking. Pause the video when you are ready to begin this section. And then when you have finished, play the video again to continue for the instructions for the next section. So now we're going to look at the signs. We've talked about positive and negative before with movement. Think back to our geometric transformations. In the next 4 bullets, I want you to remind yourself what is positive, what is negative. So write plus or minus in the space for when you move up, down, right, or left. And then looking at our stair example again, remember I told you you were going to need those ratios again. So from number 5, 6, and 8, rewrite those ratios right here. For the single stair, the 6th stair, and the full staircase. This time, you're going to choose whether it's a positive value or a negative value depending on its movement. Depending on what you wrote here, if it moved up, you'll circle the positive. If it moved down, you'll circle the negative, and so forth. So in this one, it could be anything like this, like this, like this, depending on whether it's moving up, right, left, or down. Then I want you to look at your rates of change, all 3 of these. Would you say that the overall rate of change would be a positive rate of change or a negative? And tell me why. You're going to repeat this, but this time thinking about walking down the stairs. So rewrite again your same ratios of 1 stair, 6 stairs, and full staircase. This shouldn't change because the distances didn't change. But what might change is your positive or negative sign, depending on whether you moved right, left, up, or down. So circle the sign for each distance. Is it 3 feet up, 3 feet right, 3 feet down, 3 feet to the left? That's just a random number. Lastly, you are going to tell me what your overall rate of change would be again, whether you think those ones would be positive or negative overall, and why. And look at the words that we're about to talk about in these next questions. I want to know, which staircase do you think represents an increasing rate of change? Think about what increasing means. And which staircase represents a decreasing rate of change? Think about what that means. Go ahead and fill in this section and play the video again when you're ready to move on. So pause it now. This next section is easy. You're just going to look at the vocabulary. Rate of change has many names. The most common name people call it, well, is rate of change, but they also call it slope. It goes by ratios, fractions, gradient even. But think about what you might have heard about the word slope. Have you ever heard the word slope before? You probably have. And think about when in your real world context. So why might we call it the slope of a line instead of rate of change? They're the same thing, but why might we use that word? Pause the video to complete this section and then press play when you're ready to complete the last section. Lastly, on this next section, what you're going to do is you are going to look at 3 different graphs and try to gather information from them. Look at their labels. For example, in this first one, we have time in weeks and we have length in millimeters. I want you to identify which one is your independent variable and which one is your dependent variable. Then I want you to try to identify what is the rate of change or the slope, just from looking at the graph. Remember to watch out for whether it's positive or negative, what we talked about in the last section. Did it go up to the right or down and to the left? So watch for your positive and negative signs. I also want you to try to figure out as a fraction, your rate of change, your slope, something per something. In this case, do you think it's going to be weeks per millimeters when we're talking about beard length, or millimeters per week when we're talking about beard length? So be careful of that. Also, to figure out the rate, be careful of your numbers. This isn't starting at 0, it's starting at 10 millimeters. And if I look at my line, we want to look for points on the line. This is a point on the line, and this is a point on the line, because it's exactly where it lands on 2 little corners of the square. If you look at this one, it's a point on the line, but that's not going to be easy for me to read, because it doesn't fall exactly on numbers written on the graph. So we can look at the comparative distance of, okay, after 0 weeks, the beard was 10 meters. And after 10 weeks, the beard was 35 meters. So how much did it grow per week? Think about that to figure out your rate of change. And remember, is it positive or negative? Try your best on these 3 because we're definitely going to go through these together. And then what I want you to look at is, what do you notice about the relationships between your rate of change? Maybe I'll make that a little bit bigger. Your rate of change and the dependent and independent variable. There should be some type of connection. So look at what you can notice there. All right, ladies and gentlemen, complete this section and turn this in for your assignment for the day. And that's all you have to do. I hope you have such a wonderful day, and thank you for joining me. Bye-bye.